This segment, I want to review some of the configuration parameters of the TEMPCO controller. Okay, to get to the parameters, you hit this E button. Once it gives you this start, stat thing, run, hold. This is something to do with the, if you want to go into auto tune or hold or start a profile, you use that stuff. We'll move on. Profiles. Now, if you've pre-programmed your profiles, this is profile 1. You want to do profile 2, 3, 4 on up to 9 profiles. You can enter and program it. We'll go over those later. Then you hit it once more time, and you're back to where you're showing the set point and your process variable, 74 in this case. Okay, so hit this twice. And then where it says profile, now in the manual it says to hold this button E for 5 seconds to get into configuration. So 1001, 1002, 1003, 1004, 1005. It doesn't do it. Well, what I found is that if you hold it for about 7 seconds, it does go into configuration mode. So 1001, 1002, 1003, 1004, 1005, 1006, 1007. Aha. So the first one, this is stuff you saw in the earlier video, but if you want to lock out these parameters for operators, you change some of the access codes from like 0 to 1000, and then that locks out that first level. But this is where you set them if you're going to lock them out. This is type J thermocouple. You can change it to K, T, whatever. We're using type J's on our process ovens typically. Degrees Fahrenheit, degrees C, or there's another one, process units. If you got percentage or something like that, we're using degrees Fahrenheit. Okay, deadband, we don't have any deadband in this thing. If you have an on-off control application, above set point, below set point, off or on, you may want to have a deadband of a couple degrees so it doesn't go chitter-chattering all over the place. But we don't worry about that. We use an SSR driver. Filter, have filter set at 1. A filter is just something to smooth out the signal from the thermocouple. In the event you're picking up some interference from some AC circuits or something like that nearby, which may cause signals to be induced in your low voltage thermocouple extension wire, but that's not the case here. But I usually put it about 1 to kind of averages over 1 second. This is a feature that has to do with what the events are programmed for in the programs, but we're gonna leave that off. Set point low, set point high. This particular system is a low temperature oven, and but if you had a higher temperature oven, 450 or whatever, this is where you set the set point limit. So an operator can't, put your 450 degree oven at a set point of 800 degrees and walk away. Although of course you also have the high limit controller, which works very similarly and would shut you down independently if the primary controller, temperature controller, this one, were to have a runaway temperature condition. Okay, so set point high. Output 1, this is what the code is for a heating application, or a reversed heating, a reversed output. Direct is cooling, but this is heating, and there you go. Output 1 filter, I believe this is. I'm not sure what that is right now, but don't worry about it. Cycle time. Cycle time is 1 second, but you could change it to 10 seconds. If it was at 10 seconds, when it called for 50% output, it would be on for 5 seconds and off for 5 seconds, or 90% would be 9 seconds and off for 1 second. However, you might do that if you had a contactor for the output or something, a mechanical contactor that was clunking off and on, and you had limited cycles before it wore out. but we're using typical in our Delta H systems, solid state relays, and they will last forever. We set it for 1 second cycle time, and since they're like big transistors, they turn off and on without any moving parts, of course. And with a 1 second cycle time, as I said earlier, if they are set up to where they 50% output, they're on a half a second, off for half a second, etc. But it happens so fast that it's gives you what's called time proportioning on-off control. So even though this is a digital discrete output of off and on, it behaves as if it's a analog output. Gives you very smooth control. Let's see, output lower limit, that, and then the output high limit is 100. If you thought the system was overheating or heating too fast, you could limit the output. If you limit the output to 60%, when it called for 100% output or 100% power, it would be on for 600 milliseconds and off for 400 milliseconds because that's a 1 second cycle time. We'll leave that at 100. Proportional band, this is a temperature range around the set point which it begins the proportional control. So if it's 15 degrees and you're 75 degrees, when you go above 90, you were at 100% output. Below 90 or 15 degree band of the set point, it'll be controlling proportionally. This is an integral function or time. It's this feature in tuning. A PID acts as a damper, like a shock absorber to a car. It measures the area under the curve when it overshoots, and we'll put a counter signal in there, so to speak, to cause it to dampen out. The derivative function is measures the slope of the climbing rate of the temperature, and such as when you close the doors, the temperature will recover very quickly, so you may not want to have the unit at 100% output because it'll overshoot. So this is a function you would increase to minimize the output when it's climbing quickly, the rate or derivative function. PB2, this thing can feature, it has another relay. It could be set up for 2 control loops, such as a cooling loop, if you wanted. If you had a fan on your system or wanted to tie that into it, they could do that. Offset is like where you think your standard output would be when you're running. You may need to adjust that later on in the system. Output 2 is, there's a relay in here, but we're not using it for right now. But it can be used for linear output. Here's some chatter in here. There's an alarm high and alarm low, reverse alarm. You can see the thing clicking, hear it maybe. And event. And then this is, you can actually have a DC output. If you want to have another analog control signal, you could do that. If you had a variable frequency drive or something on a fan, you can do those things. But we'll leave it at none. But it's available if you wish to use it as a customer. Output 3, there's no output 3, neither 5. And then this is a feature where you can tell it which one of these selection things you want it to address, don't worry about that. And it goes through that, and then you're back to the beginning. But we just hit E, and you're back.